In this last lesson of the unit, we're going to be focusing on mathematical practices, ways that we can use what we've been learning in this unit in the real world. I'd like you to start drawing on your background knowledge about birds. What materials do birds use to build a nest? Where can birds' nests be found? And why do birds build nests in the first place? What do you think this nest was made out of? And where do you think it's located? What about these nests? What kind of materials do you think were used for these? Where do you think you might find these kinds of nests? And finally, what about this one? What materials do you see in this nest? And where do you think this nest is located? You might have already known that some birds nest in shrubs and trees, while others prefer to nest in birdhouses, which are man-made structures that are built to attract and house birds above the ground, like these here. In today's activity, we're going to be using fractions to calculate the wood and the dimensions that we're going to need for constructing or building a birdhouse. So let's find out what kind of birdhouse you're going to be constructing. Have you ever seen a birdhouse? Birdhouses offer birds a place to rest and keep their eggs safe from predators. Purple martins are birds that nest in colonies. Purple martin birdhouses, like the one on the right, are sometimes called bird hotels. Suppose that a 5th grade class has decided to build a 2-story purple martin bird hotel. Each story of the hotel will have 6 identical compartments. 1, 2, 3, 4, 5, 6. The bird hotel will be made from wood, and each story will have the following characteristics. The inside dimensions of each compartment, which there are 6 of, measure 6 1/3 inches by 6 1/3 inches by 6 1/3 inches. What this means is that each of these little rooms for each bird is identical, and each of them are actually just kind of like a cube. If you were to cover the top and the bottom, you would have a cube because all sides would be exactly the same. So what we see is that we have a length, a width, and a height of 6 1/3 inches. The next compartment over would be the exact same thing. You would have a length, a width, and a height of 6 1/3 inches. And your last compartment would be a length, a width, and a height of 6 1/3 inches. That covers 3 of the compartments, and we could label the back 3 over here the exact same. There's 3 other compartments. So essentially we have 6 compartments, all have the exact same measurements. All the birds have the exact same room. This only covers the interior of the first floor, so we have some more information about the exterior of this house. Now we know the wood that's used for the exterior walls is 3/4 of an inch thick. The exterior walls are going to be on the outside, and the thickness of it is going to be this portion right here of the wall. And it would be important, of course, to know how thick that is if we wanted to cover this first floor with a roof. Then we would need to know the entire length of the first floor, and that thickness would be a part of that. So we're going to say the thickness here is 3/4 of an inch. Our final piece of information is going to be that the wood used for the interior walls is 1/6 of an inch thick. Here we're talking about the inside walls, which you can see visually are thinner, and that would be this portion right here. The thickness of it is only going to be 1/6 of an inch thick. So we'll label that 1/6 of an inch. We're dealing in inches here with all of our measurements. So I'm going to take just a second now to recreate this and label it so we can see exactly what we're looking at. Okay, so what I've done here now is I blew it up a little bit and I labeled everything that I knew. And we knew that the inside of each compartment measured 6 1/3 inches by 6 1/3 inches, also by 6 1/3 inches high. So what we could do is just draw a little arrow going up and write 6 1/3 inches there as well. And that's going to be the same for each compartment. I also labeled the edges, which we knew on the outside walls, the edges were 3/4 inches thick. And we knew on the inside, we could tell that those were thinner. They were only 1/5 of an inch thick on the inside wall. So all that has been labeled. And now we have our question finally. The question's over on the right-hand side here. It's calculate the length, the width, and the height of one story. Do not include a floor or a ceiling in your calculations. So I figured we would start with the easier of the calculations, which would be the height. We actually already know the height and it won't take any calculations because as we look at our first compartment over here, we see that the height was 6 1/3 inches, just like the length and the width was. So the height is already done for you. It will be 6 1/3 inches. When figuring out the width or the length, the first thing we need to do is determine which side is the length, which side is the width. And in this case, I'm going to use the smaller side as the width. That would be this side here. We'll label that width. Of course, that's going to make the adjacent side is going to be our length. And now it's our job to figure out how wide it's going to be and how long it's going to be. And we could see that might be useful, especially when we're going to add a story to this and we're going to have to probably add a roof. So we're going to want to know the length and the width so we can measure those out and have our roof fit properly. Since now we've already determined which side our width is going to be, we want to measure. If we had a tape measure, we would simply just attach the tape measure to the top of our structure and measure from the top to the bottom, just like that. But since we don't have one, we're going to have to use the numbers that we know and add them together to find the total width. So let's talk about and see exactly what it is we're going to have to be adding together and how many numbers is that going to be. So if we attach the tape measure to the top side, we would have to measure first the width of the thickness of the outside walls. Then we would have to measure this wall here and the thickness of this interior wall and this wall here and the thickness of the other exterior wall. So as we look at that, we have the first thickness of the exterior wall on the top right here, which is only 3/4 of an inch thick, plus the width of the first compartment, which is 6 1/3 inches thick, plus the thickness of the first interior wall, this part right here, which is only 1/5 of an inch thick, plus the next width of the final compartment, which is also 6 1/3 inches thick, and finally the thickness of the last wall, the last outer wall, which is 3/4 of an inch thick. If we add all of those together, we'll have the total width of our first story of this birdhouse. When I start to attack a problem like this, I know I have a couple of choices. I could try to find a common denominator and change all of my fractions to the same denominator, But I notice that I have a lot of fractions that already have the same denominator. So I think what I'm going to do is group those fractions and add them separately, and then add them all together in the end. So if I added my 6 1/3 and 6 1/3, I could do that in my head. I know 6 and 6 is 12, and 1 is 2, so it's going to end up being 12 2/3. We'll write that down over here. 12 2/3. And then we will add our other group of fractions here, 3/4 and 3/4, which will give us 6/4. And then we'll have to add to that 1/5. So now I'll rewrite those fractions. We have 12 2/3 plus 6/4 plus 1/5. Now I have only 3 fractions to add, but I still have 3 fractions with different denominators. So I have a couple of options here. I could again try to find a common denominator for all 3 fractions. That may not be a bad idea. Or I could add 2 fractions at a time and then total in the 3rd fraction after that. If I wanted to find a common denominator for all 3 fractions, I could do it the same way I would do with just 2 fractions. I could multiply my 3 denominators together. I would get 5 times 4 is 20, times 3 is 60. That would be a common denominator that would work. There may be a smaller one, but this is the quickest way to do that. And now I would go ahead and fill in my numerators, my rules. The rule for the top fraction is going to be times 20. 2 times 20 would equal 40. The rule for my second fraction would be times 15. So we'll do 6 times 15. That's going to be 90. And my third fraction, the rule is going to be times 12. And that will make a numerator of 12. Now we can add our numerators, starting in the ones column. 2 plus 0 plus 0 is 2. And 4 plus 9 plus 1. 9 plus 1 is 10, plus 4 is 14, so you get 142 over 60, and our whole numbers add up to 12. We can see that we have an improper fraction that we need to fix, so we need to ask ourselves, how many times will 60 go into 142? It'll go in there 2 times, and 60 times 2 is 120, so that would leave us with 22 left over out of 60. This fraction here is still not simplified, but we have our 12 plus our 2, which gives us 14, and our 22/60ths, which needs to be simplified. We could divide by 2 on the top and bottom to do that, and we'll end up with 11 over 30. So now we know our width, which is going to end up being 14 and 11/30ths of an inch. Now we still need to find the length. We can put our 14 and 11/30ths here. Erase all this work and go back to work and finding the length of our first story. And if we recall, our length is going to be this portion right here, from one end to the other. And so we need to start writing down the fractions that we're going to need to be adding together in order to find the length. So we'll start at one end here, and we realize that we're going to need the width of the outer wall, which is right there, this part. That's 3/4 of an inch. We're also going to need the length of this portion here, which is 6 1/3 of an inch, because that's one of the interior walls as well. And then we need to know the width or the thickness of the inside slat, the inside part of the walls. We know that the thickness there is 1/5 of an inch, so we're going to have to add 1/5 there. Then we have another long one, which is 6 1/3. Another thickness to the inside wall, which is 1/5. Another long portion of the wall, which is 6 1/3. And then our final thickness of the outside wall, which is 3/4. All right, we're going to have to add all of these fractions together. It's a lot of fractions. Again, we can start grouping them, though, into groups of fractions that have the same denominator and make our job a little simpler. We have 2 3/4 that we have to add, and we have 2 1/5 that we have to add. So I'll start by adding my largest one, my 6 1/3. 6 1/3, 3 times is going to get a 6 times 3, which is 18, and 1/3 and 1/3 and 1/3 is 3/3, which is equal to 1. So I have 18 plus 1, which is 19. That takes care of our 6 1/3. Then I can add my 3/4 plus my 3/4, which will get me 6/4, which is improper, but okay for now. And I also, to finish off, I'll have my 1/5 and my 1/5, which is going to get me 2/5. And so now I have a simpler problem. I have 19 plus 6/4 plus 2/5, just two fractions to add and a whole number. As I'm adding these up, I need to find a common denominator. I'm going to just simply use the easiest method, which is multiply my two denominators and get 20. My numerator on top will have a multiple of 5, so that will be 30. My numerator on bottom will have a multiple of 4, so that will be 8. I can now add, get 38 over 20. My whole number is still 19. Check my fraction to see if it's improper. It is improper. We'll fix that fraction. 20 goes into 38 one time, and there will be, when it's only one time, it's already lined up, so we could just subtract. So there will be 18 left over out of 20. That fraction needs to be simplified by dividing. We can divide that fraction by 2. We'll do that in just a second. We'll add our whole numbers. 19 plus 1 is 20. Our fraction was 18 over 20. We know we had to simplify that. We could divide by 2 and get ourselves 9/10. So now we know that our length is now 20 9/10 of an inch. Now you might need to rewind this as you go through the problems in the workbook, but on page 29 of the workbook you'll be working on the exact same problems but with different dimensions. So use this video to help you with that. So I'm going to write my 12 2/3 and go back